All right, let's talk about that specific kind of pain you only feel in a lab. You know the one. It's that moment your Nmap scan finally finishes and you're just staring at that soul-crushing message, 0 hosts up. You lose 20 minutes, then 40, and pretty soon you're questioning everything. Your network, your VPN, maybe even your life choices. Well, today, we are gonna fix that, and we're gonna fix it fast.
We have all been there. You know the machine is online. The instructions say it's there, but your tools are basically laughing at you. It's so frustrating, and it's one of the biggest time sinks you can possibly face. But here's the thing. The problem isn't the host, and it's definitely not your sanity.
So that's the real question, isn't it? We're going to break down exactly why Nmap does this, and more importantly, I'm going to give you a repeatable 2-command baseline that will save you hours. This is all about making a smart choice between speed and certainty without your scan turning into a total timeout marathon.
Okay, so let's get right to the root of it. When we see a ping fail, our brain immediately jumps to, oh, the host must be down. But in the world of Nmap, especially in these lab environments, that's almost always the wrong conclusion to jump to. The issue isn't the host, it's the probe.
This right here is the central myth we have to bust. When most of us say ping, we're thinking of that classic ICMP echo request. But Nmap, it is so much smarter than that. Its host discovery isn't just one action. It's a whole flexible system, a toolkit of different probes it uses to ask the network, hey, are you alive?
See, if you're on the same local network, Nmap's probably just going to send an ARP request. It's super fast, super reliable. But the second you're scanning across a VPN or a different subnet, everything changes. It has to switch to other methods, like different kinds of ICMP probes, or even sending little TCP packets to common web ports like 80 and 443. So if a firewall somewhere is set to just drop one of those specific probe types, your entire discovery phase can just completely fail.
And this analogy is just perfect. It illustrates the situation so well, right? Just because the doorbell is broken, or in our case, the ICMP probe gets filtered out, that doesn't mean no one's home. You just use the wrong method to check. You got to try knocking on the door directly, and that's exactly what we're about to do.
So this is the crucial mental shift you have to make. From now on, when Nmap says host seems down, you have to translate that in your head. It doesn't mean the host is offline. It means this host did not reply to the specific discovery probes I sent it. This is a huge clue about the network's filtering rules, not a final verdict on whether the host exists.
All right, so let's get to the solution. We have two main flags to get around this, -SN and -PN. Now, they might look similar, but they ask two fundamentally different questions. Understanding that difference, well, that's the whole key to efficient scanning.
Let's break this down because it's so important. Over on one side, you've got SN. Think of this as a discovery-only scan. It basically just shouts who's alive out there, but it doesn't bother doing a port scan. It is fantastic for a quick head count on a network where you're pretty sure your probes will get through. Then you have PN. This one doesn't ask permission at all. It tells Nmap to completely skip the discovery phase and just assume every single target you provided is online. It goes straight to the port scan. This is your tool for absolute certainty, but here's the trade-off. It can be way slower and a lot noisier, especially if you point it at a huge range of IPs.
So, how do you choose? It's not about which flag is just better. It's about which one is better for the job right in front of you. This really just comes down to a simple choice between needing speed or needing certainty. So let's walk through a little framework for making that call.
Here's your process. Super simple. First, just ask yourself, am I on the same local network, or am I coming in over a VPN or a different subnet? If you're local, a discovery scan with SN is probably going to be fast and reliable. If you're remote, there's a good chance something's getting filtered. So based on that, you choose your weapon. And here's the most important part, number 3, calibrate. Before you scan a massive 24, just test your chosen flag on like 3 to 5 IPs. See what up actually looks like in this environment.
Now this brings us to the two mistakes that will absolutely destroy your momentum. The first one is treating that host seems down message as gospel. You have to remember, it's just a conclusion Nmap made based on a very specific set of probes. If you can internalize that, you stop panicking and you start problem solving with a different method.
And the second trap is overcorrecting. You learn that PN is reliable, so you just start carpet bombing entire subnets with it from the get-go. This turns what should be a quick look around into a slow, painful grind. You've just traded one problem for another. The real key is to use PN like a scalpel on smaller, more focused target sets, not as a sledgehammer.
So let's put this all together into one final, actionable takeaway. This is all about building a simple, repeatable strategy you can count on every single time you step into a new network. This is how you get consistent and trustworthy results. Here it is, 4 easy steps. 1. Pick a tiny slice of your targets. 2. Run your fast discovery scan, SN. See what happens. Do you get replies back? 3. Run your certainty scan, SPN, on that exact same small set. And now compare. Does it suddenly find hosts the first scan missed? Boom, you're calibrated. You now understand the rules of this network. And only then do you expand your scan to the bigger range, using the method you just proved actually works here.
And you know, if you remember just one single thing from all this, make it this right here. Nmap is your tool for speed when the network is playing nice. Nping is your tool for reliability when the network is trying to hide things from you. Your job is just to figure out which kind of network you're on and to do it quickly.
So the takeaway here isn't just theory, it is a call to action. Seriously, the next time you're in a lab, take 10 minutes and just run this quick calibration process. Figure out what an up host actually looks like in that specific environment. Because once you do that, every single scan you run after is going to be a confident, strategic decision, and not just a hopeful guess.